Hello everyone. Just waiting for more attendees to join. Sharp 3 p.m. will start. Good afternoon, all. I welcome you all at today's webinar on increasing offsite construction with BIM. Today's speakers are Aftab, Deepika, and Shivreddy. The agendas for today's webinar is Introduction to Desapex will be taken care by me, Deepika. What's offsite construction and why do we need it? Methods of offsite construction. What are the key differentiating factors between traditional and offsite construction will be taken care by Aftab. Industrialized construction and the mega trends of the industrialized construction. How digital twin could benefit modular construction will be taken care by Shiv Reddy. So now let me take you through Desapex intro. Desapex is a digital engineering organization working towards digital technology integration in the AEC industry to improve the life cycle of a built assets. We provide complete digital solutions throughout the life cycle of the building or infrastructure, that is design, construction, and operation. Desapex aims to create a sustainable built environment by enabling digital adoption and integration of technologies for target value design. We are headquartered at Bangalore and also we are operating from 3 major cities in India. Those are Chennai, Hubli, and Hyderabad. And we are serving our clients across the globe. These are some of the customer segments which we are serving, starting from hotels and restaurant, corporate real estate, residential, airport, data centers, rail, metro, logistic and warehouse, factory buildings, retail, and infrastructure. So wherever there is a capital expenditure and operation expenditure involved, we provide digital solutions over there. There are 3 verticals of Desapex: digital design management, digital project management, digital asset management. Under the digital design management, we provide the solution for clash detection and coordination, including architectural, structural, mechanical, electrical, plumbing, and firefighting modeling, and also BIM-based pre-construction services. At Desapex, we provide our clients to translate the conventional 2D drawings into the 3D BIM models and perform the simulations before we even go to the construction sites. Under the digital project management, we are providing to our clients to manage their construction projects digitally, where we provide a digital information delivery plan, technical due diligence, and setting up of a digital lab. And the digital asset management here we assist our clients to digitize their project document in terms of the latest as-built 2D drawings into 3D BIM models. And we also digitize the existing physical building, like the building after the handover stage or during the operation stage. We are partnered with Finnish company Gronlund. We have an integrated tool called as Gronlund Manager, which is used to provide the solution like BIM for facility management, in which we provide maintenance management, energy management, asset management, and also real estate portfolio management services using the BIM model. Regarding digital twins using reality capture, here we build models by using laser scanning technology. We are going to develop BIM models using reality capture data, and that model can be further used for as-built verification and documentation and also construction progress monitoring. We have developed a team capable of integrating design and construction parameters into digital information model, which blends the expertise in domain, process, and tool and provide the owner an unmatched performance, and this our approach to deliver quality projects on time. This is our young, passionate team, and we have civil, mechanical, architecture, and electrical BIM engineers. This part is the USP of Desapex. I feel very proud to say that we are the first company in the world and only company in India to have this kite mark from the British Standard Institute, which is a global standards for BIM, and it is ISO 19650 Part 1 and 2. This is all about Desapex for portfolio. I would like to hand over now to Mr. Aftab for further session. Over to you, Aftab.
Thank you, Deepika, for introducing Desapex. Good afternoon, everyone. As introduced, I am Aftab, associated with Desapex as a senior project coordinator. I hope everyone's doing well today. In this session, we will be discussing about what is offsite construction and why do we need it. Discussing about the different methods of prefab construction. What are the key differentiating factors between traditional and offsite construction? Before we jump into the topic, I would like to request our participants to answer this quick poll to understand the professional background of our audience. It will be available for the next 10 seconds. Poll option is available to your left side of the screen. You can choose one of these among whichever is relevant to your role. Please take your time and to answer this question. Thank you, everyone. Now let's begin with our topic. There is no doubt that technology is causing significant disruption in the construction industry. In construction projects, robotics, augmented reality, and even drones are being used. However, the biggest disruptor in the construction sector over the next 10 years may be one of the industry's oldest ideas, that is offsite construction. Offsite construction, also called as prefab construction, is a construction procedure that involves planning, designing, fabrication, transportation of fabricated building items, and its assembling on site with great speed and high degree of precision. The work is divided into two stages. The first is the manufacturing of the components, which takes place in the factories or the other locations other than the final location. And the second is the erection of the structure in its final position. The various prefabricated sections are mass produced and then shipped to various construction sites. Before being used in construction, precast concrete units are hardened and cast. However, buildings will sometimes cast components on the job site and hoist them into place once they have hardened. Offsite construction is becoming more popular, with many businesses realizing the benefits of moving the building process away from the physical site and into a controlled factory environment. Here are some of the reasons why offsite is the next big thing. First one is the efficient construction method. When materials and buildings are constructed off-site, efficiency is almost guaranteed. Weather elements such as wind, rain, frost, and snow can make worksite construction uncertain. When components are assembled in a controlled factory environment, this complication does not exist. Offsite construction provides the advantage of being able to correctly forecast a building project's timeline. Construction occurs in a controlled environment and can be far more automated than the traditional on-site brick-by-brick approach. Building a kitchen and bathroom in a factory, in particular, allows the room with the most complex mechanical and engineering components to be prefabricated and transported to the site. This reduces the need to coordinate labors with diverse skill sets who are frequently employed by multiple subcontractors who are required to construct kitchens and bathrooms on site. Because the process of offsite construction is consistent, the time required to finish construction is substantially decreased, making it more efficient, time-saving, and cost-effective ways to build. Next one is construction safety and better working conditions. Transferring work off-site to a controlled environment enhances safety. It is far safer for construction workers to assemble house components in a factory controlled setting than on site. Because offsite construction is much more predictable setting with the same construction process every time, it significantly reduces hazards such as falls from great heights, equipment mishaps, and personal injuries. Offsite factory-based settings can make it easier to meet and regulate safety regulations, which leads to greater build quality through improved quality control procedures. Next one is environmentally friendly. One of the key benefits of offsite building is that waste is reduced. Construction and demolition are two of the world's major trash generators. Offsite construction allows builders to work in a factory-controlled environment, allowing them to more properly calculate the required building materials. They can also have numerous construction projects running concurrently in one place, allowing for material optimization. This, in turn, provides for a reduction in building waste through resource efficiency. There has recently been a strong push for greener building practices because manufacturers can regulate energy and emission more effectively than on-site construction. Off-site construction is more sustainable and environmental friendly manner of construction process. This type of construction approach is a tried and true means of lowering greenhouse gas emissions. Offsite construction requires less heavy machinery and consumes significantly less energy than traditional techniques of construction. Next one is less labor. According to studies, constructing a structure in a factory setting requires significantly less labor. According to the Steel Construction Institute, the number of hands necessary for a 4-story residential development might be lowered by up to 75% with equivalent reduction in other types of construction. Of course, fewer employees implies lower labor expenditure for the organization. The next one is no disruption to the residents. Those unfortunate enough to reside nearby may find their presence severely tested by an on-site development. Aside from the noise and pollution caused by heavy gear and equipment, construction and delivery vehicles moving to and from the site can cause traffic delays as well as impede parking spots and access routes. This is especially problematic in congested metropolitan settings. Furthermore, building sites and cranes are never attractive and can be a nuisance for an extended period of time. Local inhabitants will benefit greatly from the relocation of development away from the site and into a factory. Now that we know what is the need for offsite construction, let's go through some of the methods of offsite construction. There are different forms through which an offsite construction can be performed. They are volumetric construction, panelized construction, hybrid construction, and sub-assemblies and accessory system. Let's look at the volumetric construction. 3-dimensional units are manufactured at the factory and then transported to the job site and fastened together. The frames might be made of steel, wood, or concrete. As part of third-party approval, the firm has quality control production system. The volumetric construction method is also known as modular construction. The modules can be purchased in many forms, such as the basic structural shell or one with internal and external finishes and services. This structure may have a frame constructed of wood or concrete, as well as light gauge steel or composite material. Volumetric construction is split into 2 parts. They are modular construction and pod construction. In modular construction, factory-produced pre-engineered building components are delivered to the construction site. These modules are then put together as a huge volumetric components or significant elements. Pods are a non-structural elements used in conjunction with load-bearing structure. They are primarily employed in the hotel and lodging building business. The enclosure might be made of timber, concrete, steel, or load-bearing structure. These 3-dimensional features are used in buildings' superstructure in this form of construction. These are ready-made rooms that can be connected to form a whole premise. They are held together by lightweight steel structure. All of the final building services are pre-installed on site, leaving the final connections. As an example, hotel bathroom, accommodation block, and kitchen unit construction, they all come under pod type of construction. Next one is panelized construction. These are flat panel modules that are utilized to make a complete structural shell in the shape of wall, floors, or roof panels. These panel units are manufactured in the factory and brought to the job site for assembly as a 3-dimensional structure or to fit into an already created structure on site. Factory-made structural flooring and roofs are also referred as cassettes. These cassettes might be either load-bearing or non-load-bearing structures. These structural panel units can be constructed from wood, insulated panels, light gauge steel, concrete, or non-structural infill walls. Such panel units can be used in any style of construction. windows, timber frames, insulation are some of the examples of building components created using panelized method. Next one is hybrid construction. In order to create a single building, hybrid construction uses both volumetric and panelized process. As a result, this construction is also known as semi-volumetric. The hybrid system are either fully made or factory prefabricated building facilities. These units have the entire final finish. Once finished, the hybrid system, also known as parts, are brought to the site. For example, highly serviced spaces such as toilets and kitchens are originally built as volumetric units, while the remainder of the house is built with panels. Next one is sub-assemblies and accessory system. The sub-assembly system is the method through which construction components are initially built on off-site before being permanently assembled on site. Building components, materials, equipment, and prefabricated parts are the example of these aspects. This method of construction entails the production of minor building components such as roofs, trusses, floor pipes, staircase, precast concrete beams, and columns. Prefabricated foundations, floor cassettes, and roof cassettes comprise the subassembly system. Now that we know what is prefabrication construction is and the different methods, let's go over the key differences between prefab and the traditional construction process. Traditional construction is what many of us associate with any sort of job site or construction zone. Land is procured upon which structures are constructed on site from the ground up, like foundations, walls, roofs, etc. Prefabricated construction flips the traditional construction on its head, delivering pre-assembled components, either flat sections or complete modules, to the job site to be assembled there. Prefabricated construction cuts cost and mitigates labor shortages by having the majority of its built structure produced off-site by third-party manufacturer. Some of the major differences associated with prefabrication and traditional construction are construction speed. Prefabricated construction also has shorter build time frame. Although traditional construction normally takes 18 to 24 months to complete, prefab can be done in 12 to 14 months or less for a given small building. Almost 20 to 50% reduction in project schedule can be expected in prefab construction. Next one is design. While traditional construction can be custom planned from the ground up, prefabrication, especially prefabricated modular construction, may be constrained by design constraints and building codes. Modular construction, on the other hand, is sometimes associated with modern, forward-thinking design aesthetics that may appeal to the younger purchasers. Furthermore, a hybrid technique can assist blend classic design components with modern-looking modules to create a contemporary look that is both aesthetically acceptable and pays attention to both of these construction approaches. Next one is seasonality. Prefabricated constructions create the major of its manufactured components indoors and offer great quality structures as opposed to traditional construction projects, which are limited to prime seasons and afflicted by external elements. That's all from me. I'm going to let my fellow co-speaker, Mr. Shivreddy, continue with the rest of the discussion. Thank you.
So good afternoon, everyone. As introduced, I am Shivareddy, associated with Desapex as a senior project coordinator. Thank you, Aftab, for the informative session on the prefabrication. So in this session, we will be knowing more about industrialized construction and the mega trends around the IC, which are termed as the future of off-site construction projects, and also how the digital twins are benefiting the off-site construction projects. So before we start with the topic, I would like to request you all to answer this poll. How many of you have engaged in some level of prefabrication projects? So take 10 seconds of your time. The options are at the left side of your screen. Thank you for your response. Starting with the main topic, that is industrialized construction. As we all know, the construction industry is one of the least digitized industries compared to other major industry sectors, where the traditional business methods still dominate the construction sector, even though the construction projects are becoming more and more complex. Though the industry has progressed vastly through the years, the future of design and construction will require all project stakeholders, that is, owners, designers, engineers, fabricators, and contractors, to adapt new technologies in their processes, regulations, and skill sets. Industrialization has already been applied to the production of goods of other industries to reduce costs, improve product quality, and deliver complex products to the mass markets. In a similar way, the application of manufacturing techniques to the built environment, right from the concept to design, pre-construction to construction, and all the way through operations of the building, is the term industrialized construction. It is the process through which the construction aims to improve productivity and advancement of construction processes through increased mechanization and automation. So talking about the mega trends in industrialized construction. So we have prefabrication, which is majorly contributing in industrialization of construction, which we have already learned about in the previous session by Aftab. I'm going to go in deep on how the technological advancement is happening in offsite construction through the additive manufacturing or the 3D printing, robotics and automation, and the digital twins. Additive manufacturing, which is commonly known as 3D printing, is at the forefront of digital fabrication. It is the computer controlled process that creates three-dimensional objects by depositing materials, which produces objects by building the structures from small deposits of material in layers. The construction industry has begun to explore additive manufacturing as an emerging building technology, mainly because of its possibility to go directly from a 3D model of an object to a finished product with one touch and one machine. It uses a wide range of materials such as steel, glass, ceramic, polymer, concrete, and more. One of the inviting advantages of 3D printing is the ability to make custom-built, complex, and unique components. Robotics and automation. The robots have already been used to do a limited range of monotonous tasks, primarily in materials and components handling. However, emerging robotic technologies used in the construction technology include the demolition robots, the 3D printing robots, bricklaying robots, welding robots, and humanoids. Robotic automation offers huge potential to enhance productivity, efficiency, and manufacturing flexibility in the fabrication of modular homes, robotic welding, and material handling during prefabrication. I am presenting a video. So here in the shop floor, the ABB robots are used here. Like they are used for handling and assembling of large section of timbers in the prefabrication production lines. Here, various robot systems are used, and they are also integrated with tracks. The robots produce timber components according to design created in Intelligent Cities Platform for Life, that is P4L's design software, enabling customized structures to the built environment. Here, also the Robot Studio offline programming software is also used along with P4L to plan task and movement for the robots, where every component gets its own file and can be simulated and exactly directed. Next is the digital twin. It is a digital replica of a physical asset where it holds all the data to do with the engineering, construction, and operations of its physical counterpart in one place. For the construction industry, these virtual replicas of building are taking their claim with great pace now. Creating a digital version of your final buildings, maybe an office building, hospital, factory, hotel, or various infrastructures like roads, bridges, etc. It can be created as a model to the physical asset to aid in the design process at pre-construction stage. It is used as a tool to lower production costs, reduce completion times, and increase sustainability. Or for already constructed buildings using laser scanning technology to lower operation cost and for facility management purposes. Major role of digital twins in prefabrication projects. It enables a clear communications for the designers, where the designers can use digital twinning as an alternative to traditional line drawings to enable improved communication and transparency between a modular construction project's key players. Designers historically work with technical line drawing, which take more time to create and can lead to delay in project schedule. By using digital twin technology, designs can be digitalized and incorporated into the main project with ease. Digital twinning streamlines this process by collecting all data related to the building, such as quantities of materials required, the measurements of components, and even factors such as energy efficiency, all within a 3D model. Any technical limitations such as building regulations can be integrated into the design algorithm, ensuring that designers have a full understanding of the project before they are started. So combining this technical information with 3D model means that the design is simpler to understand than a line drawing. So any discrepancies between design and expectation will be easier to identify. And alterations can be inputted into the digital twin and designer can modify their existing model. This is considerably quicker than the traditional process, which often involves starting a new line drawings from scratch if any changes to be made. About the design quality, digital twinning can also improve the quality of modular project since the components are made offsite. Modular construction requires the measurement and quantities of building components to be accurate. If the construction of the component differs even slightly from its design, the modules will not fix together correctly, which can increase the project cost and cost delays. A digital twin contains the exact measurement and quantities for each of the building, be it a wall, roof, or windows and doors. Since the digital twin is an exact replica of the future physical building, the data it collects is guaranteed to be correct. This means the project managers can be confident in the precision of their brief when communicating with the contractors. Constructing individual parts offsite in exact quantities will further reduce the build's completion time. It will also eliminate the need to order materials in excess, which is strategy often implemented to offset any unexpected delays. And the continuous improvement. Even once the construction is complete, the digital twinning can help maintain the physical building. The Internet of Things (IoT) uses sensors to capture the data of a building's mechanical and electrical systems. These sensors can be connected to the digital twin for continuous real-time monitoring of all information related to building in one accessible place. This data can be used to predict part replacements, identify energy efficiency issues, and act on potential security threats. If a completed modular building's windows and doors display large amount of heat loss, for example, this data can be fed back to the building's manager, who may use it to consider purchasing a replacement item from a reliable supplier. Not only is this useful for building managers who will be able to carry out the maintenance more effectively, it can also be used to improve future designs. And the data captured from the existing building can show the designers how the building performs, and they can be given as a feedback to design more efficiently in the future. This is particularly useful for modular construction because the same components are continuously being made by the contractors, and therefore the data from previous projects will be relevant to future ones too. The building information modeling combined with fabrication has enabled integrated architecture and engineering workflows that can embrace prefabrication, which has become more significant in building design and construction. So here, as we can see, the data from the 3D model is fed to the machineries and the output is being prepared. So with this, we can say, definitely the prefabrications should be seen as an opportunity to increase the efficiency and productivity of the current construction industry. Prefabrication is said to be the first step in achieving industrialization in the construction industry, and the benefits have already been realized in many manufacturing industries. Though the external factors, including the availability of finance, land supply, public perception, and demand, will affect the success of prefabrication, the higher degree of industrialization are being achieved through mechanization, automation, and robotics now. And although the traditional construction methods may be able to satisfy current demands, the companies that continue to be successful into the future must develop innovative products and processes, and they must address the growing environmental concerns associated with construction. There is a growing need to change the way we build, and the prefabrication is a step in the right direction. So with this, I can say digital methodologies are the future for all prefabrication projects. May it be digital twins or the BIM and virtual design and construction, which are acting as the integration for modular construction, enhancing the communication flow among the project participants. And we at Desapex are at the forefront in supporting digitization of construction industry, and all the services we provide are in line with term digital, which is the future. Hope the session was informative and helpful. That's all from my side. Over to you, Deepika.
Thank you, Aftab and Shivreddy, for sharing your valuable insights. I hope all of you have a brief knowledge about our session. If anyone has any questions, can drop their question in the chat box.
So here is one question on how the laser scanning technology will benefit the prefabrication. So when we have the need of exact replica of an existing old building, like which is of around 200 or like very old buildings, so there we can have the laser scanning and get the data of it. So from that we can like develop the digital twins, like, and the final output can be given for the prefabrication of the exact replica.
Module is a three-dimensional structure. It's like a box, like covered with panels in all sides. So it's basically a box. That's what you call a module. So how sustainability is involved. Okay. So when we reduce the waste and when the methods are quality controlled, the materials that we use, I mean, the amount of material that we use, it becomes less. So that's how we reduce the material wastage and everything. And because the construction happens off-site, so the pollution will be lesser. So that's how the sustainability is maintained in this kind of construction.
So thank you, And I would like to thank each and everyone for joining us, and we will connect again soon, and we will bring more and more interesting topics in our industry. So stay tuned with the Desapex at LinkedIn and all our social media platforms. For that, I request you all to take a minute and scan this QR code. Thank you. Thank you so much.